I want to remind you of something that you learned in Algebra 1. It's called the zero product property. If I tell you that I'm multiplying two numbers together and the result is 0, what do you know about one of those numbers? One of them must be 0. So next, if I tell you that one of those numbers is x minus 3 and the other number is x plus 2, that means that x minus 3 must equal 0 or x plus 2 must equal 0. So what x value would make x minus 3 equal 0? What number minus 3 is 0? 3. And what x value would make the second set of parentheses equal to 0? Negative 2. That concept, which is called the zero product property simply means if you end up with 0 as the result of a product, like multiplication, it means that one of those things has to be 0 or both of them have to be 0. This ties into intercept form because that's exactly how you find the x-intercepts for the equation. So intercept form is helping you find the x-intercepts. So you need to make a note that intercept form does not mean y-intercept, it means the x-intercepts. And also remember, we talked about that the x-intercepts, there's 4 words that they use with quadratic functions that mean x-intercepts. So you could say x-intercepts, you could say solutions, you could say roots, you could say zeros. Intercept form looks like this. Okay, A still does everything that we're familiar with A doing. So it controls whether the graph opens upward or downward, how wide or how narrow it is. Everything that you're used to with A still does. X minus P times X minus Q. P and Q are the x-intercepts. X-intercepts always have a y value of 0. So if you put 0 in place of this f of x, you're looking for what x value will make the first set of parentheses equal 0? P. What x value will make the second set of parentheses equal 0? Q. So that's really what you're doing. But the shortcut is basically take the opposite of whatever number is in the parentheses. So up above we had x minus 3. The opposite of negative 3 is positive 3. The opposite of positive 2 was negative 2. So you're taking the opposite of the number. Then, how to find the maximum or minimum value. The axis of symmetry is exactly halfway between the x-intercepts. So in the writing up above, they actually give you a formula for the axis of symmetry. It's that x equals p plus q divided by 2. That formula is really just finding the average of the two x-intercepts. Add the two numbers together and divide by the number of numbers. So you could do p plus q, figure out what that is, and divide by 2. The more common method is put a finger on each x-intercept and then count in until your fingers meet. So you're finding the x value that is exactly between those two x-intercepts. Once you have that x value from the axis of symmetry, remember that your vertex is your axis of symmetry, comma, something. So plug it in to find the y value. I would strongly recommend that you write down step-by-step instructions so that if you're looking at your notes later and like, wait, why did we do that? You'll know what we did. The first step is going to be identify or find your X-intercepts. One way is to think about the zero product property. If f of x was 0, what x value would make the first set of parentheses equal 0? What x value would make the second set of parentheses equal 0? The shortcut is I see plus 2, so one of the intercepts is negative 2. What's the other intercept? Positive 4. So on your x-axis, remember these are your x-intercepts, negative 2 and positive 4. Your axis of symmetry is halfway between negative 2 and 4. So the math book would like you to take negative 2 plus 4 and then divide by 2, but realistically, the visual people that we are, put a finger on each intercept and count in, where do they meet? At 1. So your axis of symmetry is x equals 1. Next, find your vertex. You now know that your vertex is 1, comma, something. How do I know the first part of my vertex is 1? Because that's the axis of symmetry. So if you need to make that connection to show yourself, to find the y value, we plug 1 into the equation that we are given. So plug in 1. 1 plus 2 times 1 minus 4. Now, when I was in high school, and sometimes even still now, I'm not always the most observant person. I thought it was kind of weird that I always seemed to have like 3 and negative 3, or 2 and negative 2, or 5 and negative 5. I'm like, oh, that's kind of interesting that those are always like the same number but opposites of each other. But if you think about it, the axis of symmetry is halfway between those 2 points. So it makes sense. There's 3 units between the left intercept and that axis of symmetry, and there's 3 units on the other side. So it makes sense that these 2 numbers match but are opposites. If they ever don't, that's a good sign that you probably did something wrong and you need to go back and look at it. So our y value is negative 9. Our vertex is 1, negative 9. And then we can draw in our parabola. Okay, graph the function, done. Label the vertex and the axis of symmetry. You probably have that information shown in your work. You don't need to write it on the graph again. That's good enough. Does the function have a maximum or a minimum value? It has a minimum because the vertex is at the bottom, and that minimum value is negative 9. And then the truly easy part, the domain, all real numbers, and the range. If the minimum is negative 9, the minimum y value is negative 9, so y is greater than or equal to negative 9. Following those steps, see if you can do part B on your own. Our x-intercepts for this function are positive 7 and positive 3. You can think about what x value will make the parentheses equal 0, or you can just take the opposite of whatever number you see in there. So 7 and 3. And probably because of the type of graph we're using, you can easily see that the axis of symmetry is 5. 5 is halfway between 7 and 3. Good gravy, that just zoomed way in to 500%. Wowza. Okay, Step 3, find your vertex. The first part of your vertex comes from your axis of symmetry. The second part you get from plugging in the first part. So 2 times 5 minus 7 times 5 minus 3, that would be 2 times negative 2 times positive 2, which is negative 8. So our parabola, this seems like a really skinny parabola. Does it make sense that our parabola is that skinny? Yes, because there's a 2 in front of the function. Now, if that 2 had been a negative 2, it wouldn't affect the x-intercepts. It would not affect the axis of symmetry. The only thing it would affect is when you plugged that 5 in. If this had been a negative 2 in front, we would have done negative 2 times negative 2 times 2, which would have put our vertex at positive 8, which definitely would have made the graph open downward. Okay, this has a minimum at negative 8. Domain, all real numbers. Range, y is greater than or equal to negative 8. If we had flipped this over, if that had been a negative 2 and your vertex was up here, then your range would have been y is less than or equal to your maximum value of positive 8. But it's not, so we can ignore that.